Okay, now let's turn our attention to some problems that have removable discontinuities, aka holes. So just like before, our first step is going to be to factor. So this would be x minus 3, x minus 1. First step in the denominator is to factor out my GCF. That leaves me with a difference of squares, so I can keep factoring. And then x plus 3, x minus 3. Notice this time I have the same factor in the numerator and denominator. I have an x minus 3 in both. So I can take that out. That's going to be a removable, aka whole. So if I cross that out, my simplified version is going to be x minus 1 over 2 times x plus 3. And we just took out an x minus 3, so our whole happens when x minus 3 equals 0. So happens when x equals 3. And we'll come back and get the y value of that whole, but I want to go ahead and write that down. So our domain we get from our entire denominator before I've canceled anything. So my denominator can't be 0, so 2 x minus 3, x plus 3, that's an x, can't be 0. 2 can't be 0, well that doesn't equal anything. X minus 3 can't be 0, so x can't be 3. And then x plus 3 can't be 0, so x cannot be negative 3. Now I know most of you can do all of that in your head, and that's totally fine. Now what we're doing is on a number line, taking out the negative 3, taking out the 3, and leaving everything else. So I'm going to clean this up and put my final answer for my domain, which will be negative infinity to negative 3 union negative 3 to 3 union 3 to infinity. Now let's look at our horizontal asymptotes. So my degree of the numerator is 2, denominator is 2, so it's going to be y equals the ratio of their coefficients. So to see if it crosses, we set our function equal to our horizontal asymptote. And I'm going to use this simplified one because I've already taken out that whole, and it's going to make my life a little bit sad if I still have that whole. So 2x minus 3, just cross multiplying, equals 2 times x minus 1. So 2x minus, 6, hello, I promise I can multiply, equals 2x minus 2. So I get negative 6 equals negative 2, which is not true. So it does not cross. X-intercept means we set our numerator, our simplified numerator, equal to 0. So 0 equals x minus 1. So I have an x-intercept at the point 1, 0. Y-intercept means we set x equal to 0, and you could do this in any equation. Doesn't matter which one. I like to do the original, but you can do whatever you want. I like the original because then I can really just do the ratio of the constants. I'm showing a lot of work right here. So y equals 3 over negative 18, which simplifying will give me the point 0, negative 1/6. Okay, so let's come back to that whole. So what we do to get the y-coordinate of the whole is we plug it in. You see up at the top right, I'm highlighting that simplified equation. So we're going to substitute 3 into that equation. So y equals 3 minus 1 in the numerator, 2 times, substituting in 3 for x, plus 3. So y equals 2 over 3 plus 3 is 6, times 2 is 12. So that would be 1/6 reduced to that. So my hole is at the point 3 1/6. For my vertical asymptote, we look in the denominator. I do still have an x left. So 2 times x plus 3 equals 0. That's going to happen when x equals -3. So let's do our sign chart. What do we put on sign charts? We put our vertical asymptote, and we put intercepts, x-intercepts. Let's be really precise. So -3 and 1, let's label. That's a vertical asymptote. This is an x-intercept. I'm going to do my sign chart from my simplified equation, x minus 1, and I'm going to start writing that extra factor here. Okay, let's talk about it though. 2, I don't have any x's, so no matter what x is, it's always going to be positive. So in this case, it doesn't change anything, but if that was negative, it would make a difference. Now I'm going to look at x minus 1. That has a critical value of 1, so it's negative everything to the left, positive everything to the right. Let's look at x plus 3. That has a critical value of -3, so we're negative to the left of that critical value, positive to the right. And then let's simplify, plus, minus, plus. Okay, we'll do our vertical asymptote limit analysis, and then we're ready to graph. So for my limit analysis, limit as x approaches, our vertical asymptote is at 3. So I'm looking at this part of my sign chart. -3 from the left of my function. To the left of that is a positive. So that means my vertical asymptote, my function will be going to positive infinity. As x approaches -3 from the right, it says minus, so that's going to be going towards negative infinity. So let's sketch some stuff. Now, I know from my prior knowledge of this problem, let's change our scale over here so that 2 blocks is equaling a unit. It'll just make us a little bit more nicely spread out right there. Okay, so let's graph our asymptotes first. So we have a horizontal asymptote at 1/2. We have a vertical asymptote at -3. We have a y-intercept at 0, -1/6. Oh, and let's make sure this is -1, -2, -3. We have an x-intercept at 1, 0. And we have a hole at 3, 1/6. So I want to make sure that's a really clear hole right there. Let's add in from our asymptotes. To the left of -3 is going up. To the right of -3 is going down. And now we look at our sign chart. Left of -3, everything's positive. And we're not crossing our horizontal asymptote. Okay. On the right side, we're negative between -3 and our x-intercept. So I'm just going to basically connect the dots at this point on the right side. Don't go through your hole. The whole point is there is a hole there, so make it obvious, like I did, that there is a hole. Done. Let's look at another example. Once again, our first step is going to be to factor. So my numerator will factor to x plus 3, x minus 3. My denominator is x plus 3, x minus 2. Notice I have the same factor, x plus 3 in the numerator and denominator. So that means I'm going to have a hole when that factor, x plus 3, equals 0. So I can go ahead and cross that out since I've written that down. So that will reduce to x minus 3 over x minus 2. So let's look at our domain. Our domain has to be before I canceled out that hole. So I can't equal -3 or 2. Think about that on a number line. that would be negative infinity to negative 3, union negative 3 to 2, union 2 to infinity. We have the same degree in the numerator and denominator once again, so it's y equals the ratio of their leading coefficients for our horizontal asymptote. Since I have a horizontal asymptote, I'm going to see if it crosses. So set your horizontal asymptote equal to your function. I'm going to use that reduced function. Cross multiply. So x minus 2 equals x minus 3. Well, those x's will cancel. I get negative 2 equals negative 3, which is not true. So this is not going to cross. Whoop, moving around today. No crossing. All right, x-intercept means I'm going to set my simplified numerator equal to 0 and solve. So x minus 3 equals 0, x equals 3, so my x-intercept is at 3, 0. Y-intercept means to plug in 0 for x. In any of my equations, that last one is really simple, so I'm going to use that one. Once again, it doesn't matter which equation you plug it into. You should get the same answer. Okay, so we already set up our whole a while ago. So my x value, my whole, if I solve, is negative 3. Now let's find the y value. To find the y value, we plug it in to the simplified equation. So my simplified equation was x minus 3, x minus 2, and I'm plugging in the x value that we just got. So y equals negative 6 over negative 5. So my whole is going to happen at negative 3 and 6/5, a little bit over 1. Vertical asymptote is anything after the whole left in the denominator. So x minus 2 equals 0. So there's a vertical asymptote at x equals 2. Let's put everything on our number line. So what goes on a number line? Vertical asymptotes, x-intercepts. So we only have 2 things on this one. 2, 3, let's label. 2 is my vertical asymptote. 3 is my x-intercept. That just helps me when I'm graphing. Let's put our factors. I only have 2 factors, x minus 3, x minus 2. So if I look at x minus 3, that critical value is at 3. Everything left is negative, right is positive. Critical value for negative, or for x minus 2 is positive 2. Left is negative, right is positive. And then we look at what our overall signs are going to be. And I get plus minus plus. Don't think it's always plus minus plus or that it always alternates. We just have some really special examples. But it is coming when that is not going to be the case. And if I throw an x squared in there, it starts making things a little bit funky. So don't overgeneralize. Let's write our vertical asymptote limit analysis. So we'll look at where my vertical asymptote is. We're going to look immediately left and right of that. So the limit as x approaches 2 from the left is going to positive infinity. The limit as x approaches 2 from the right is positive infinity. All right, so let's start drawing stuff. Once again, I'm going to change my scale on here so that every square is a half unit on my y-axis, just so that I have not squished everything. You may notice a lot of the same numbers come up. That's because otherwise these problems get kind of really big. Okay, so I have a horizontal asymptote at 1. I have a vertical asymptote at 2. I have a x-intercept at 3, 0. I have a y-intercept at 1.5. I have a whole at negative 3 and 6/5. So 6/5 is just going to be a little bit over 1. And we know we're not crossing. So let's start with our limit analysis. Let's look where our arrows go. So to the left of my vertical asymptote, we're going up. To the right, I'm going down. And now let's connect the dots. So I know that to the left of my vertical asymptote, everything is positive, and that I don't cross my horizontal asymptote. So we're just going to connect just like that. Then I'm negative between my vertical asymptote and my x-intercept. So connect that arrow to my x-intercept. And then I'm positive after. I'm not crossing through my horizontal asymptote. So that's my final graph.